Hi, this is your first chemistry tutorial, and today we'll be covering the first chapter in your syllabus, that's periodic table of elements. Now, there are two very basic parts of this chapter. It's pretty clearly divided. One, in simple words, the one that doesn't come in your exam, the other that really does. The first one is all about the history and discovery of the atom and elements. And I'm just going to go quickly through it. There's not much you need to know really, it's all just for your knowledge. And if you're taking chemistry or science in in class 11 or something, then it'll come of use to you. Uh, and the second part of the chapter is the more important one, much more relevant to you. It covers the variation in periodic properties of elements as you go across the table. That's very important. And it forms the basis of chemical bonding as well, which we'll be doing later. So, just to skip through this first part, John Dalton, you need to know him. He's one of the first chemists who really researched about the model of the atom as well as elements. And he proposed a few theories. Not all of them were correct. Some of them have been proven wrong now, but he did form the basis and the fundamental for other scientists' research as well. Then there was Dobrina's triads. Dobrina, he was a scientist who grouped triplets, three elements who had similar chemical properties, and also interestingly, he also said that the atomic weight of the middle element in the three is the average of the atomic weight of the other two. It's not really important because nothing really came out of this. There were only a few triplets like these triads, and nothing came of it. Then there was octave, a Newlands Law of Octaves, where Newlands arranged rows of 7 elements together. He numbered them and he arranged them like the notes of music, hence 7. And his arrangement is significant because for the first time, he was the first person to actually arrange them in the form of numbers. He gave the elements certain numbers, and today in the modern periodic table, that is the basic thing: atomic weight and mass number. So his contribution is pretty important. Then Mendeleev, he too gave his version of the periodic table, and it's possibly the closest to the modern periodic table. He arranged cards on a table. All of them had one element on them. What he did was he arranged them in order of increasing atomic weight, which is very, very important. Even today, that is done in the modern periodic table. And by doing that, at the same time, he got elements with similar properties in the same column. And in the modern periodic table too, that's a case where elements of the same group have similar properties. But of course, it did have some defects. Isotopes, there was no place for isotopes in his table. The position of hydrogen also, it wasn't very clear. So he was close, but not quite spot on. That's about it for this section. It's not very important, but if you do want to know more about this, then I'm referring to Anita Prasad's chemistry textbook, ICSE, for 2012. So if you want, you can read more, but that's it for now, and we'll be covering the next section right now.
Hi guys, I'm going to be covering the second portion of the first chapter, which is periodic table, with you. Basically, this portion is all about periodicity of physical properties of elements. There are 7 major important physical properties like size of the atom, ionization potential, electron affinity, electronegativity, metallic character, and non-metallic character. Alright, so these are the major important physical properties that we're going to cover in our syllabus. They're pretty easy to understand as well. However, if you don't pay attention, then I don't think you're going to get them. So before we start, I'm pretty sure you must have noticed these rather amusing creatures here. Well, basically these three things are some very basic concepts. For example, what this denotes here is that a positive loves a negative, or a positive attracts a negative charge. Similarly, now this right here is a gun, by the way, with a bullet coming out of it. So this right here indicates that a positive loads a positive. Loads meaning a positive hits a positive, or a positive charge repels a positive charge. And this one right here indicates that a negative charge again repels a negative charge. So my friends, unlike charges attract each other, and like charges repel each other. Alright, so now we start with the first important physical property, which is atomic size. Hang on, let me just delete these. Where is my brush? Alright, there we go. Alright guys, now let's just start with the first physical property, which is atomic. I'm sorry, my handwriting is pretty useless, but you'll have to bear with me. Radius. Alright, it's also known as atomic size, and as the name suggests, it's basically. Alright, let's consider the example of hydrogen, which is pretty simple atom. Now this is the nucleus. This is the first shell, and in hydrogen we have only one electron. This is the electron, right? So when we talk about the atomic radius of hydrogen, we consider the center of the nucleus to the electron, to the outermost electron, and in this case the outermost electron lies in the first shell. So this, my friends, will be our atomic radius, denoted by R. Alright guys, now let's consider another example. This right here is a periodic table, and let's consider helium. So let me draw the nucleus. We usually denote it by NP, where N stands for neutrons and P for protons, and I'm pretty sure all of you know that nucleus consists of neutrons and protons. This is the first shell. This right here is helium. Helium has 2 electrons, guys. It has 2 electrons in the first shell. And so now if you see, because there are 2 electrons, one more than hydrogen, therefore the overall nuclear attraction between the nucleus and the electron, basically you can consider the entire thing as a shell, will increase. Now since the nucleus is positively charged and the electrons are negatively charged, the overall nuclear attraction will increase, thereby reducing this distance. Mind you, the electrostatic force of attraction between the nucleus and the electrons will reduce the distance between the nucleus and the shells, and therefore your atomic radius will be less than the original one, as denoted in hydrogen. So this case we have R less than small r, where small r is the radius of hydrogen and capital R is the radius of helium. Also guys, I forgot to mention this point, that in helium there are 2 protons, whereas in hydrogen there is only 1 proton. And if we consider the charge E between 1 proton and 1 electron, the overall charge here would be 1e. However, here, since there are 2 electrons and 2 protons, the overall charge would be 2e. And so 2e is greater than e, and therefore this r, which is the radius of helium, is smaller than the radius of hydrogen. And now I guess we're already crossed our time limit. Thanks for listening, guys, and we're gonna continue with this portion in the next video.